have the intermediate value theorem. What is the intermediate value theorem? What does the word intermediate mean? Middle. And way to go, whoever said that. Probably Isaiah. All right, so it's middle. It's somewhere in between. It's somewhere in the middle, in between. It doesn't have to be the exact middle, but somewhere in between. So, the intermediate value theorem describes something about continuous functions. Okay, if a function is continuous and you have like a small x value and a small y value and a big x value and a big y value, there must be some value in between that's in between the x value and y value. Okay, which would like make total common sense. Well, there's got to be x values and y values in between those values. Okay, so, whoops. So, more formally, it means that any value of a limit between f of a and f of b, there's a value c in between a and b where f of c equals that. So it could go up and down, but there's going to be some value that actually equals some certain limit. So here's a continuous function between the closed interval of -1 to 4, where g sub 1, this is the x value, equals -4, this is the y value, and g of 4, this is the x value, equals 1, this is the y value. So at -1, we're at -4, and at 4, we're at 1. So we don't know what's going on in between here. Well, that was cool. We don't know what's going on in between here, but are you... We don't know what's going on in between there, but there must be, since this is at 1, okay, we don't know if it goes all the way up to 3, do we? No. But since we're at -4 on this one and a +1 on this one, we get rid of these two, and we know that there has to be a -3, because -3 is in between -4 and a +1, right? So there has to be some y value of -3 on that continuous function somewhere in between our first x value and our last x value. So the only answer is B. That's the intermediate value theorem. There has to be something in between. If it's a continuous function, there has to be something in between those values. Okay? And so they'll shoot out random stuff. Okay? But you got to look closely at it and see which ones mean what. Okay? So the y value of 3, a y value of 3, which is like right here somewhere, or -3, down here somewhere. A y value of 3 has to occur somewhere in between there if it's a continuous function. It keeps going. Okay, here's a continuous function in between -2 and 1. These are the x values. These are the y values. So, which intervals must contain a value of a 2? Okay, for a y value of 2. Does the first interval have to contain a y value of a 2? No, because it goes from 4 to 3. It doesn't cross past 2, so no, that doesn't have to contain that value. Does from 3 to -1 have to contain 2 if it's a continuous function? Yes, it does. Does -1 to 1 have to contain a 2? No. So it's just the -1 to 0 is the only one that works for that one. Okay? Between 1 and 6, how many places have to contain a 0? Does it have to contain a 0 on the first ones? No. Second ones? Yes. Third ones? Yes. So from 3 to 4 and 4 to 6 have to contain a 0. because it crosses the, x-axis basically, both those places. Okay? The table gives you a value of continuous functions. Below is Elliott's attempt to write a justification for the fact of the equation that h equals 9, that you have a 9 somewhere in between -5 and -4. He said that we have a continuous function. You must, in the intermediate value theorem, say it is continuous. If it's not continuous, the intermediate value theorem doesn't apply. You have to say something about being continuous. So he says it's continuous. If this is at 12 and this is at 8 and 9 is in between 12 and 8, thus the intermediate value theorem applies. Okay? So he established that h is continuous. He established that 9 was in between the h of 5 and h of 4. So, yes, his justification is complete. So you'll maybe hit a couple of those where you have to make sure their justification is complete, or if they're missing something. Here's a table of values for a continuous. It says continuous there, so we know it's continuous. Can we use the intermediate value theorem to say that we have a y value of 0 somewhere in between -4 and 2? Can we use that to say there's a 0 there? No, we cannot. No. We know it's continuous, but since 0 isn't in between these two y values, no, we cannot establish that. Okay, we cannot establish that. Can we use the intermediate value theorem that we have a 0.5 when we go from -1 to 1? Now, did we establish that this is a continuous function anywhere? No, we don't say it's a continuous function. And if you actually graph it, you can see it's not a continuous function because at 0, it's an asymptote. So it's not a continuous function. If it's not a continuous function and 0 is in between -1 and 1, then you can't use the intermediate value theorem. It has to be continuous. Okay? Are we good with that? Intermediate value theorem, and of course we'll have a quiz right after that, and then that's it for this week. I hope that wasn't too confusing.